So Ceres has a very low obliquity, which is the angle between its orbit and its pole. The Earth's obliquity is 20 something degrees, 22, 23 degrees, and that's why we have summer and winter. Ceres' obliquity is almost zero, so it doesn't really have much in the way of seasons. But it also means that very close to its pole, you can potentially keep ice. We don't have the resolution, the spatial resolution to see to see if there's ice near the poles of Ceres or not. Dawn will definitely get that information. For the rest of Ceres, closer to its equator, it's too warm to really keep ice around for very long. So we think what might have happened is one of a couple things, like in this plot here. So when Ceres formed and it differentiated, like Katie said, we think maybe into an ice mantle over a rocky crust. The very top of Ceres would still potentially be rock, and that would be heavier than the ice. So we think that would kind of sink down through the ice and the water. That would put the ice on top. But you can't really keep the ice on top because it's too warm for the ice. So that ice would then start to sublime away. For those non-scientists out there, basically evaporate, but evaporate means something technically different. So it's about start to sublime away and leave whatever kind of maybe collected in the ice behind. So we think that would be one way you'd get sort of these brucite and carbonate minerals at the surface of Ceres, is by leaving what we call a lag deposit. The ice would go away and leave whatever junk had collected in the ice behind. So that's one possibility. The second possible way of getting this brucite and carbonate on the surface would be the other plot, which is cryovolcanism. Cryovolcanism is a kind of specific term, which basically means volcanism, except you use ice for the magma and the lava instead of rock like we see on volcanoes here on Earth. And here the idea would be that you kind of have still a rocky crust, or some kind of crust, but if you manage to punch holes in that via either impacts or just the natural extensional stresses that you'd find, you might get ice to come up through that hole and kind of have an icy magma, an icy lava. And then you have the same situation where the ice maybe drags stuff up with it. It's too warm to keep the ice on the surface, so the ice goes away and leaves the stuff it dragged behind. So hopefully we'll be able to determine which of those two things is going on Ceres. Certainly, when Dawn shows up, it'll give us a lot more data, a lot closer images, and hopefully that'll help us out.